where does transactional memory originate from? It was invented by Tom Knight, who is notable for several things, such as starting to study at MIT partly from age 14. And he built the network interface for the sixth computer connected to ARPANET, which became Internet. And he registered the first .com address, continued to work at MIT and Thinking Machines, and founded a scientific field, synthetic biology. And his paper about transactional memory was published in 1986. So it's very suitable to use Lisp-based language for one part of our study on transactional memory, and the other part, of course, hardware-based transactional memory in C. Okay. 1986 was also the year when Michel Dubois published a paper on weak ordering, which pioneered the relaxed memory model. So that's an important year. The first hardware-implemented transactional memory CPU was unfortunately only a prototype, and it was made at Sun Microsystems. Sun pioneered the workstation market, and they created many interesting things, including Java and the Spark CPU, and made a sophisticated multiprocessor version of Unix called Solaris for their machines. They were very early at exploiting multiprocessors. Okay, so this CPU, it was presented at the main computer architecture conference, International Symposium on Computer Architecture in 2009. And what is interesting for students from Lund is that one of the authors was Anders Landin, was a D student at LTH. And well, then after that he moved to Swedish Institute of Computer Science to participate in the research on cache-only memory architectures that I mentioned in an earlier lecture, COMA, and in particular on the DDM project. The financial crisis for mostly for the United States, but well, it doesn't matter for other countries in this context, but many of Sun's customers had severe problems and went out of business, and Oracle could buy it. Okay, and what the owner of, well, the boss of Oracle, Larry Ellison, he decided to cancel this CPU. But there was another machine from IBM, the Blue Gene supercomputer. So this is a very big machine, as we can see, and it's somewhat costly. Each rack costs more than $1 million, and there are a few. And here are some data for each. It contains 16 cores, and it's 4-level simultaneous multi-threading. Okay, simultaneous multi-threading, I will talk about that in a later lecture, but recall, it's a flexible way of running either one hardware thread or up to 4 hardware threads in the same pipeline. So that for workloads that require one super fast CPU, it's better to just use one thread. And if there instead are multiple threads or concurrent programs that should run quickly, then one can switch to SMT4 and run all 4 at the same time. And the idea then, of course, is that when one thread gets cache miss and has to wait several hundred clock cycles, there is probably another thread that can continue using the pipeline. Okay. So how can one do transactional memory in hardware? Note that superscalar CPUs, those which can start more than one instruction at the same clock cycle, they have to run instructions speculatively, otherwise there is too little to do. But store instructions, they are not allowed to be speculated normally. Okay, so how can one then run transactions which in a sense are speculative, or at least they have to be, it must be possible to cancel them. And what is done is that the writes, I mean the stores, they are done to the second level cache, and with the cache block there is also versioned, so that if there is a need to cancel a transaction, then the cache blocks with a certain version can be removed. Okay, some parameters. Each chip has 16 cores with up to 4 hardware threads, as mentioned before, and each core has 16 kilobytes of first level cache. That's quite small, and these cores, they share a 32 megabyte second level cache. So as mentioned, the speculative writes are saved in the L2 cache, and after a commit they become visible to other threads.